Segmented Cement Logs Workflow. This video will demonstrate the workflow to evaluate annular cement using segmented sonic tools in EMERAUDE. The cement raw data are imported by loading survey data typically stored as a DLIS file to include arrays. Segmented tools produce amplitude maps that can be used for azimuthal analysis of the annular cement. In this example, the segmented receiver is located 2 feet away from the emitter, while in other tools the distance is 3 feet. A VDL is also included. The relevant curves are loaded and unnecessary channels omitted. When the Array Properties window pops up, the Diameters tab is entered to select the nominal pipe diameter in the catalog list. Next, in the Array Data Properties tab, a CCL and a CBL are associated to the array. In this example, the cement map is already orientated using the relative bearing. If this were not the case, the association of a relative bearing would automatically orientate the image. These types of logs include a large number of curves, which can be conveniently arranged using templates. The Well Integrity Templates folder contains templates for the various tools. In this video, we will proceed without templates to understand the data included in the file. The unwanted logs are hidden away. And the segmented map and the VDL displayed. The segmented map is an unwrapped image of the amplitudes measured by the 8 sectors. In this particular tool, the image is orientated for bearing. The individual curves that form the map are typically included with the raw data. A user view is created. And the sector's amplitudes dragged and dropped from the browser. Large differences between sectors' amplitudes indicate channeling. The amplitudes of these curves are used to set the minimum and maximum of the color scale of the sector's map. The azimuthal variability of the amplitude becomes evident. A new user view is created to display the transit times measured by the 8 sectors, dragging and dropping them from the browser. Zooming in, differences between these curves indicate the tool eccentricity. Finally, the color scale of the VDL is modified. The cement evaluation workflow is conducted from the Well Integrity tab. The first icon corresponds to the bond index and attenuation calculations. The selection of the endpoints can be done interactively on the CBL track. Right-clicking on bond index and attenuation on the CBL track shows free pipe and 100% bonded levels. The Edit option is selected in the right-click menu, and the endpoints are interactively edited by moving the red and green lines. In this case, the free pipe amplitude is found at just below the dual casing interval. For 100% bonded, the interval minimum CBL is selected, which corresponds to the largest VDL attenuation and circumferential coverage as seen in the map. These values can be manually edited from the Bond Index dialog. If the tool is properly calibrated, the nominal free pipe amplitude for this pipe size can be entered. The Bond Index and attenuation tracks are created. The Fill Areas option is used to highlight the intervals with bond index larger than 0.8. The casing to cement bond evaluation requires good and acceptable CBL amplitudes. These are based on the type of cement, casing size, and qualitative analysis of the VDL. The cement flags track shows the intervals of good, acceptable, and bad cement using color coding. Note that the connections between casing joints result in spikes in the CBL, which in turn lead to bands of poor cement. Connections must be identified and removed from the analysis. Right-click on the sectors map and select Explore. Click on Show and select the CBL and CCL. Using the Interactive Joints Identification option, the vertical line is placed so it intersects the CCL peaks corresponding to the connections. Due to the quality of the CCL, the connections identification is not successful in an interval of the log. Right-click on the CBL track and use the Joints ID Select Range option. First, the depth range for joints identification is selected, and then the CBL value is set. If after applying these options there are still intervals where the joints were not identified, use the manual option to interactively define the joints. The sectors map can be displayed in 3D. By default, a single casing joint is displayed. Clicking on Navigator and unchecking the Joints box allows selecting a specific interval, which can be larger or smaller than a single joint. High amplitude corresponds to low attenuations, which indicates poor or no cement. The filter option is used to remove the data above a certain amplitude to highlight channels in the annular cement. Leave the Explore with OK. The next step of the cement evaluation workflow is to set the formation zones in intervals where the VDL exhibits formation arrivals. To facilitate the detection of formation arrivals, a new user view is created, and the VDL and the gamma ray are dropped. Modify the horizontal scale so the gamma ray curve sits in the middle of the VDL. In intervals where the cement does not contact the formation, the changes in lithology do not impact on the mid-time VDL arrivals. However, if there is good cement to formation bond, changes in the gamma ray coincide with mid-time wiggly lines in the VDL. The formation flags are interactively set in intervals with formation arrivals. The final step of the cement evaluation workflow is to identify intervals with channeling. It is not necessary to define the channels in intervals where the cement flags already indicate bad cement, but it is critical to do it in intervals with good or acceptable cement. It may be necessary to change the color scale of the map to highlight channels. The three criteria are combined to obtain a single result per depth. The results table shows the zonal results and overall isolation flags. The Exclude Connections option is ticked, meaning that these intervals are excluded from the final analysis. Overall isolation results are also presented in a dedicated track. This summarizes at every depth the potential of annular isolation given by the cement. This concludes this video on segmented cement locks workflow in EMERAUDE.